Welcome to the CNCF Salzburg meetup in April 2023. We are really happy to host Juliano today, who's talking about OpenTelemetry. He's also the co-organizer of CNCF Linz, so also go there and watch the talks there. Are also really good. Yeah, and we're really happy to see what is coming. And yeah, it's your stage, Juliano.
Thank you. Thanks for the introduction. Thanks for the invite, Christian and Johannes. So today I'm going to talk about how to get started with OpenTelemetry and mainly focusing on the OpenTelemetry demo. For the ones who don't know, OTel is the short for OpenTelemetry. It's kind of the alias and cool name of it. So if I say OTel, please read OpenTelemetry. So from now on, before we start, who am I? So I'm Juliano. I'm originally from Brazil, living in Austria for a little bit more than 4 years. I'm a senior software engineer at Dynatrace. I've been nominated in the spring 2023, so for a year, CNCF ambassador as well. As Christian mentioned, I run the CNCF meetup in Linz with a friend of mine, Jürgen, and we do monthly events every last or second last Tuesday of the month. And so we have once a month, and we do the events in person. So if you're around and you want to join, please sign up to the CNCF, cncf.community.com/links, or you can also find us on meetup.com. And I'm also an OpenTelemetry demo maintainer. The OpenTelemetry demo is a demo that showcases OpenTelemetry. I will talk about that more towards the end of the talk, where I'm going to show OpenTelemetry in action. And yeah, that's basically me. So the agenda for today, I'm gonna, as we are doing an introduction, I'm gonna do a bit of contextualization, and then we talk about what is OpenTelemetry. Then we go over signals, instrumentation, the collector, which is a component from the OpenTelemetry, and then the OpenTelemetry demo itself with some hands-on, and of course, time for questions. So yeah, let's give a bit of context to everyone, so everyone is on the same page. How things worked in the past. So in the past, you had your application, and let's say that you want to monitor your application somehow, and you want to get some metrics or whatever. You want to see what is going on within your application. So in the past, you simply go and say, hey, I want to use vendor A. So you go and you install, or you instrument your code, or you do whatever vendor A asks you to do in order to be able to monitor your application. And then you have vendor A within your application. And this component from the vendor A will send everything that it gets from your application to the vendor A backend. And by sending is most probably using a proprietary protocol. So that's totally related to vendor A. Let's say that a couple of years later, you want to restructure, change vendors, you found a new vendor, or just because of pricing, you want a new experience, and you want to switch from vendor A to vendor B. Then what you need to do, you uninstall everything that you had from vendor A, and then you install vendor B, also sending its own protocol, and then everything will be sent to the vendor B backend. Great, and so on. So if you want to switch again later, you have vendor C, proprietary protocol, and then vendor C backend. And the industry actually saw that this was a mess, and so because each observability backend had its own instrumentation libraries and agents for emitting the data to the tools. And this was like, hey, if we had like 50 different backends, we would have 50 different ways of instrumenting the application. So the cloud community um, saw that they needed a standard, and they came together. And what was funny is that kind of almost at the same time, two projects were created. So open tracing was created from the CNCF side to standardize that, and open census from the Google community open source also created to standardize that. So then we had two open source projects trying to solve the same issue. And then basically that's what we had. So like, hey, we have 14 competing standards. Oh, this is ridiculous. We need a universal one. Great. And that in the future now we have 15 competing standards, or in our case 16, because two came together to kind of try to solve the same problem. But thankfully they kind of saw that they were competing, and that wasn't the goal. So they decided to deprecate their own and discontinue their own solution in order to merge into OpenTelemetry. And that's how OpenTelemetry came up. So that was around 2019. So OpenTracing and merged with OpenCensus, and they became OpenTelemetry, a CNCF project. But what is OpenTelemetry? It's a vendor-neutral, open source observability framework. It is used for instrumenting, generating, collecting, and exporting telemetry data. And I think the most important part is that it's an industry standard and natively supported by multiple vendors. So then what happened now? You have your application and you want to monitor your application. You just go and you install OpenTelemetry. And if you want to send OpenTelemetry data to vendor A, you just use the OpenTelemetry protocol, OTLP, and send the data to vendor A. Well, here I'm assuming vendor A supports the OpenTelemetry protocol. There is the collector that I will mention later that kind of can translate that for us. But to keep it simple, you send from your application the OTLP data into vendor A, and a couple of years later, you need to switch. Great, you just change from vendor A to vendor B, and your data goes to the vendor B. And again, later, yeah, you just switch to vendor C. So I'm a big fan of the project, and what makes me a huge fan is like, now you are not stuck with a vendor because your whole system has vendor stuff, you know. Now you are with a vendor because you want, or because the vendor is good and what you get from that vendor, it gives you benefits. So you have this choice, and the power is on your hand once your application is instrumented with OpenTelemetry. Great. So what we get with OpenTelemetry? We have something that we call signals. And the signals are a category of telemetry. And we have currently four. They call one of them is called the signal, but I will not touch that in this talk. But we have mainly traces, metrics, and logs. And they also mention in the, I left the source at the bottom, so I will share the slides later on. If they also mention baggage as one of the signals. For this talk, we're gonna focus on trace, metrics, and logs. Baggage is a whole other thing that we do not need to worry about now. So yeah, great. So we have those three signals. And what are those signals? So traces. A trace we can think about as so let's imagine a distributed system, and we have a request arriving. So let's imagine e-commerce service where you have add to cart button on your page. So whenever your user clicks on add to cart, this starts a bunch of transactions. Those transactions are called spans, and the whole thing, everything that was triggered from this click belongs to one trace. So the trace is made of one or more spans, and the spans represents the unit of work or operation. So it tracks each specific request and kinds of gives you an overview of the whole transaction. Usually in tools that you have trace support, you would see something like that, where you have a bunch of bars. So each bar of this would be a span, and this shows the duration of that specific span. So then, for instance, here we get a request on the front end page. The front end needs to list the recommendations for that specific user. The front end will call list recommendations from the recommendation service. Let's say that you have a different service that is able to get recommendations for a specific user. Then to list the recommendation, we need to get the product list. To get the product list, we gonna call the product catalog, and the product catalog calls the database. So we have all these spans, all these transactions, they all belong to the same trace. So everything started with this get request on the front end, and all of them have a duration. This is traces in a high level overview. Cool. We also have metrics. A metric is a measurement about a service captured at runtime. So it has a measurement, the time that was captured, and also metadata. It is, you may be familiar with some metrics like response time and CPU consumption, but what is also nice from OpenTelemetry is that you can define some of your own metrics. And we also have that in the demo where we create some counters to count specific elements and specific requests. I will show you later on. And last but not least, logs. And I think from all the signals, logs is the most known one because everyone uses logs since their first Hello World app. And this was something that the OpenTelemetry community had to kind of sit together and decide how they would tackle that, because they didn't want to bring and create a new logging framework or a new logging library like OTLP logging library, because most of the applications already have logs. So then they decided to embrace those existing solutions and make the OpenTelemetry work with those logging libraries. And this is awesome because what will happen in the future is that OpenTelemetry will simply kind of enhance the loggings by, for instance, adding the trace ID with the logs. So then you can kind of track the trace together with the logs. And this is already happening for some of the languages, and I will show you also in the demo how that works. So basically now you have not just logs, but logs in context. Cool. So, okay, we know what OpenTelemetry is, we know the signals, but how do we get that? So like how we add OpenTelemetry into our code. And that's where instrumentation comes in. So in order to make your application observable, you need to instrument it. And at the moment, we have three different ways of doing it. Of course, depending on the language you are using. Currently, OpenTelemetry supports officially 11 different languages. In the demo, we have 10. It's just missing Swift, but not all of them support the three different ways of doing. But yeah, I will mention that a little bit later. So let's just talk about the three different ways. So the first way is automatic instrumentation, where basically as user, you do not need to do anything. Just say, hey, I want to use OpenTelemetry or something like that. For instance, for Java, you can get the OpenTelemetry agent, add to your application, and add this to the Java tools environment variable. So whenever your Java application starts, it will get this the Java agent into the startup command, and as soon as your application starts, your application will start producing traces metrics. And if you're using a supported log library, the logs will be adapted as well. So all of that by just adding one component into your application. There is also the instrumentation library. So this is I can say like a semi-automatic way. So let's say that you are using let's say that your application calls a database, let's say MySQL, and you want to monitor the calls that your application is doing to the database. Great. So you can check, there is this instrumentation library for MySQL in OpenTelemetry. So you just go to your dependencies and add this instrumentation library into it. And whenever your application starts, it kind of, depending on the instrumentation library, you may need to call it like once or twice, and maybe configure one or two lines in your code, but like not too much configuration. And then whenever once you start your application, whenever there is a call to database, this instrumentation library knows that you want to monitor that and kind of creates the trace for you based on this based on what it knows how you are supposed to use the instrumentation library. So how it's supposed to use the library. So whenever there is a call to the database, it is instrumented for you automatically. And of course, there is the manual instrumentation. By manual, I mean like really manual. So you open your code and then you go and say, hey, whenever I get a GET request here, I want to create a span. So then you go, you say, hey, OpenTelemetry, new span. Of course, it depends on the language and how you're gonna write it. But then you go and you say, hey, I want a new span here. This span will last till the end of my method. And then in the end of your method, you just span.end and you close your span. So you create a span manually. This approach is the one that requires more changes on your code. Well, I think it's expected, and you need to configure everything on it. So when the span starts, when the span ends, also if you're doing metrics, when the metrics, when you add, when you subtract, or whatever count you are using, you need to define everything manually, and also how to export whatever you are creating, so traces and metrics. So you need to define how you're going to export that into your backend, or let's say the collector. When using instrumentation libraries, you also need to do that, but most of them, they support environment variables. So the easiest way is to simply do the instrumentation that it is required and just pass the instrumentation, the environment variables to send the spans or to send the traces, send the metrics, and send the logs to a specific endpoint. And one of the coolest components from OpenTelemetry, the collector. So the collector is a vendor agnostic way of receiving, processing, and exporting telemetry data. And we can call it a proxy or maybe a converter or yeah. You can do a lot of stuff with the collector. I think we can have a talk only about the collector. Maybe I can come back later in one talk just for this one. But basically, the collector receives, process, and exports. Why is that? And what is that? And why is that? So let's say that you instrumented your code with OpenTelemetry and everything, and then you want to send your metrics and traces to a backend. So let's say that you use vendor A. You would need to go to your environment variables for that application and say, hey, the vendor A, I'm sending the traces to vendor A. I'm sending the metrics to vendor A and logs to vendor A. Great. Everything is there. And if you need to change later in the future, you would go to your application and change the environment variables. So if we are talking about microservices and let's say you have 10 microservices, you need to configure that in the 10 microservices. And that would be like 10 times that you need to configure the environment variables to traces, metrics, and logs. So we have like at least 30 environment variables to change, which is not ideal. So what you can do is configure a collector, and then all those microservices will send the traces, metrics, and logs to your collector. Then in your collector, you configure to receive, for instance, OTLP, which is OpenTelemetry protocol. It receives the OTLP. You can process that. By process, you can, for instance, add metadata. You can also do some sampling. Let's say that your backend charges per trace received or per let's say let's call it observability data. Let's say that your backend charges you per observability data received. So you may not want to send everything. So you can configure in your processor to have some sampling and send, let's say, 25% of everything that you receive, but 100% of the failures. So then you receive all the failed requests plus 25% of all traces that you receive. This is something that you can do within the processor, and the exporter is to where you're gonna send. And here it's great because in the exporter you can say something like that. Hey, I received OTLP data. Great. Now I'm gonna export that. And to export, I want to export that also in OTLP data to vendor A. Great. And then the vendor A supports OTLP. But there are some vendors that they do not support OTLP, and that's fine. You just deploy the collector, and then they have an exporter for their specific backend. So then you receive OTLP. So then your code, your application is all with OpenTelemetry and all with OTLP. And then within the exporter in the collector, you just say, hey, I want to export to vendor A. I want to export in the vendor A protocol. And then the collector will do the conversion for you and send the trace metrics or logs to that vendor. You as user, you do not need to do anything. And let's say that later you want to change from vendor A to vendor B, you just go to your collector config and change this exporter. Or even better, let's say that you want to compare, let's say that you are doing a POC to see which vendor you should use. You can come to your collector and say, hey, I'm gonna receive from my application OpenTelemetry protocol, and I want to export to vendor A, vendor B, vendor C, and vendor A protocol, OTLP protocol to vendor B, and vendor C protocol. So like you can send the same data to 3 different vendors in different protocols if you want, or depending on the vendor support. And once you have the data into the vendor backend, then you can compare the 3 vendors, how they behave, what are the benefits for each one of them, the pricing and everything. So collector, huge fan of it. If you want to know more, I also left the link here to the configuration, but I will show the OTel demo configuration. And yeah, so basically that was the talk. Now we're gonna go to actually see this in practice. So
Juliano, we had a question in the
cool.
meantime.
Mm-hmm.
There was a question by Sergio. He was asking, I have used the automatic instrumentation in Java in Kubernetes, or for Java
Awesome.
in Kubernetes,
Mm-hmm.
and the pod now takes more time to start. Is there any way to reduce the latency there?
That's a good point, and I think that's what most of the vendors try to avoid. So like when you have the vendor and you instrument your application with the vendor, they want to avoid impacting your application. I don't know, with the OpenTelemetry, you have this type of support. So using the agent there, you will get an increase on your consumption there. And what you can try to do, Sergio, is maybe, so the OpenTelemetry agent for Java, it kind of ships the whole thing. So you may try to kind of specify what exactly you are using by either just saying, I think for the OpenTelemetry Java agent, you can suppress some libraries, and that may start faster, but I'm not 100% sure. I think the best way would be to simply ask on the GitHub to discuss, because that shouldn't be the case. If it's taking longer and if it is something that is actually affecting your application, maybe then it's a bug, and then the team needs to work on improving it. But maybe just a suggestion from someone that comes from the observability, one of the vendors, maybe try to reduce what you are adding to your application. I think in the on the Kubernetes operator, you can define what you want to instrument, and if you can just specify the libraries that you are using, then it's I guess you get something better.
Okay, thank you. Then go on with the demo.
Cool.
We have 20 minutes left or something like that. So.
Okay. Yeah. Great. So the demo is, this is the diagram of the demo. It is a bunch of services. We have the legend here at the bottom. So each different color is one different language. From all the supported languages that we have, the only thing that is not in the demo is Swift, but all the others are here. We have, in most of the cases, we have automatic, we have instrumentation libraries, and we also have manual instrumentation. So for instance, for For C++, the currency service is totally manually instrumented. We define when we start, when we end the span, and everything that I mentioned before. But for instance, for Envoy supports OpenTelemetry, and then we just added a configuration within the Envoy configuration. We just added like OpenTelemetry config within the Envoy configuration, and then whenever it starts, it produces traces and send that to the collector. So we have different ways depending on the language. We also have a load gen, so we do not need to worry about accessing the application and generating traffic, but this the Envoy is also exposing to the internet, so you can actually access the page if you want. Cool. Let's do some hands-on. So I have the OpenTelemetry demo. This is the repo. I have the demo cloned already. If it is the first time you are using, you can deploy in using Docker or Kubernetes. And for the sake of simplicity, I'll reuse the Docker Compose approach. And I already built the demo, so for me it will be faster. But if it is the first time that you are using, it may take a while to fetch all the images. So by simply Docker Compose up, this will start everything. Well, if you don't want to see the logs, you can run with -d to run detached. We will not look at the logs, but I'll let it here so we see it. And so Kafka takes a while to launch. As soon as Kafka is up, we should be able to access. And we see here what we are able to access. So we are able to access the web store on 8080. We have Grafana. We have a feature flag UI. We have a load generator that we can configure. And we have Jaeger, which is a backend for traces. So yeah, let's take a look if this is running. Yeah, it is. Great. So let me maximize. No, that's actually too much. Let me hide this one. We do not need to keep looking at it. Great. So this is the web page. It's a e-commerce. We can buy astronomy stuff and also a book. It has some currency management. So let's say that I want to pay in dollars and everything is converted to dollar. No, I'm in Europe, so I want to pay in euros. Great. So you select the product, add to cart, like a normal why is my cart empty? There you go. Sorry, I had something cached. Like a normal e-commerce. So you have a shopping cart with the items that you added and a fake shipping address, a fake payment method, and you place the order. Bam, order is complete. Confirmation email was sent. Great. So as we saw in the slides, we have all the services, and when we navigate through it, everything is being called each by gRPC calls or HTTP calls, depending on the service, depending if HTTP is supported or not. In some cases, for instance, I think for Ruby, gRPC was supported, but it was increasing too much the build time, so we decided to switch to HTTP. But yeah, the important part is that we have gRPC and HTTP calls going through. And great, so everything that I've done here, and if I go to Jaeger and kind of find traces, we will see that I have 18 different services, and all of them are here. So you can say, hey, I want to go to front end and find all traces. So you
My headset just died. Can you hear me? I think I lost you.
Yes. No,
Yes,
no, we still
Yeah.
hear you.
We can still hear you.
Okay, great.
Just continue without the headset.
Yeah, no, the headset just turned it off. Like, yeah. Okay, but if you can hear me, then it's fine. Awesome. So here in Jaeger, we are checking the front end, and we can just see a bunch of each one of those is a trace, and the trace is composed by, let's say, 3 spans, 2 spans, or let me see one here from, let's say, a service that is more close to the end of the transaction, so quote service. Great. So this one has like 48 spans. We can open it, and like a little bit nicer than what I showed on the slides. So you actually see like the duration of each span, how long it took, each call. So each different color here is a different service. And you also have some metadata. By metadata, you have in Jaeger, they call it tags and processes and process, sorry, but those are in OpenTelemetry language. Resource. So we have span attributes, that is the tag, and we have resource attribute, that is the process. Basically, the resource attribute is the same for all the front end spans, but the span attribute is different for each span. So if I open here, for instance, this one here, we see that they are both running on the same container. So we see the container ID is the same, OS type and everything. So like this is common by on the two of them. But if I open the tags, which are span attributes, they are different and they are based on each one of them. So like here, the instrumentation library is the instrumentation gRPC, and here, sorry, and here we have, do we have an instrumentation library here? No.
Juliano,
So,
can
yeah.
you increase the font size a little bit on the browser?
Ah, yes, sorry.
Thank you. It's better.
Maybe I can even do that. Yeah, cool. Yeah, just let me know, Christian. Thank you. So yeah, we see like the whole operation. The naming convention in Jaeger is a bit different from OpenTelemetry because Jaeger came before OpenTelemetry, and they just kept their own naming. But yeah, I mean, once you are used to it, then it's fine. What is also cool here is that let me just go to the localhost again, and at the bottom here I have my session ID. So if I copy that, come to Jaeger and say, hey, from the front end, I want all the, now it's gonna be tricky. I think it's app.service.id equals, and then I pass the service ID and find traces. Nope. Maybe I have an underscore here. Also no. Great. Well, let me do something different then. In the demo, I have the feature flag. The feature flag, I can say, hey, I want to fail whenever a specific product is called. I want to enable cache recommendation, and I want to fail whenever add service is called. And so I can come here, edit, enable this, save. So now product catalog failure is on. and I can come to here, go to the product catalog service. You remove this because that didn't work as I wanted. So I have error. So then I can filter like error equals true. Okay, great. So now I just have the spans, the traces that are that contain some error, and then I can navigate here and see like exceptions and everything. So this is from the front end, and also the product catalog here. Also some events. Those are OpenTelemetry events that are arriving and setting the status code of the span to error. Cool. Let's take a look into some code. This is the demo. This is the repo, and there are a couple of stuff here that is interesting to take a look. One is the env file, which contains all the environment variables used in the demo. Not much to actually change here, unless you are, let's say, you want to change to where you are sending the span or something like that. But that wouldn't be the place to change. But it's nice to see all the configuration, because when you go to the Docker Compose, we see that we have just the reference to the environment variables, but the values are always stored on the .env file. So if you want
Juliano,
to
can
see
you also increase it by 1 again? So I think then we'll Control plus.
Yeah, perfect.
Yeah, so it's good now.
Awesome. Thank you. So yeah, again, environment variables here, and all the services you can build locally or use the ones that we pushed every release to Docker Hub and GitHub registry. If you want to change the service and play around with a specific language, you can also run Docker Compose build and the service name. All the code is under source. And this is what is great from the demo, because let's say that you are working with Java. So then you can come to the service that is written in Java, so add service, and see how the demo is handling the generation of everything. So the first thing that we do, as I mentioned before, we get here we are using the automatic instrumentation. So we get the 124.0 from the OpenTelemetry Java instrumentation. Basically, we download the OpenTelemetry Java jar from the repo, and we add that to Java 2 options with this Java agent. And whenever the add service is started, it gets this environment variable, and the agent is started with the app. Besides that, we also do some code changes. So within the code itself, if we take a look here, we have some meter where we count the add request by request and response time. I will show you this in a second in Grafana. And we also, so whenever, give me just a moment just to find here, whenever the get adds is called, we have, we get the current span. So this is being already created by the instrumentation. So we just get it, and then we add some more attributes. And this is great because with the auto instrumentation, you will have the request. So whenever a get request is called, the HTTP instrumentation will see, okay, I'm receiving a request and I'll create a span. Perfect. But this may not be meaningful in the business side for you. So let's say that you actually want to, let's say whenever a request fails, you want to get the user ID of that request had. So you can actually add attributes, for instance, span.set attributes, user ID, and then you add your user ID here. So whenever we get a failure, you can go to the span and have the ID within it. So if I come here into the ad service and check, I think Jaeger just died. Sorry, I'm filtering. If I come here and check the ad service, I will see that I have those, everything that is app dot is it's a convention for the OpenTelemetry demo that those are manual attributes. So all those here, those 5 attributes are manual attributes. It's added added manually. Well, if they are manual, they're added manually. Yeah, but I think you got the idea. And also a counter. So whenever we get ads, we also add a counter that will count add by 1, passing those attributes. So let's take a look into this. It's basically this batch Grafana. And in Grafana, we have some dashboards already that you can take a look if you want. So let's say the demo dashboard, we have recommendation service here, some counts, and you can, oh, I thought I had the service here. No. Okay, let me check another one. So for the collector, yeah, perfect. In this case, we can, well, yeah. Well, we see the metrics here, but I want to see this metric that we created. So I'll go to a new dashboard, add a panel, and then in here, let me just maximize this. Let me first get the name here. Is it called apps, ads? Cool. So maximize this one. And then in here, I can just say, hey, I want this metric. I didn't need to actually copy because it was the first one. So ads request. And then I have labels to filter, but I can simply run the query. And let's say last 15 minutes, you have the counter here. I also added a currency counter. So then we can count how many times a currency code was created. So if I run this query, we see here, for instance, Canadian dollar, euro, and US dollar, and how many times we got it, how many times it was used. So every time someone selects a currency, then this is created, and we add a counter to this here. So we can actually see this in the currency service, which is written in C++. And I can get rid of all those messages. And we have it here. So we have a currency counter that just adds 1 and gets a label key value. So this currency counter is adds 1 every time we get a request to convert, and the to code is to, so we always convert from one currency to another, and then we get the code, the to, and just add 1. So this is how we use the currency counter. Another thing that is nice from the demo is that for add service, that is Java, and recommendation service, that is Python, we already have OpenTelemetry logs. For the recommendation service, that happens automatically for us. So not really any, so let me just, so not really any environment variable setting that. So basically all those, the only thing that we set is log correlation equals true. And then for the add service, we had OTel logs exporter OTLP, and that was it. Unfortunately, at the moment, we do not have any tool to configure in the demo to ingest logs, but Dynatrace has one, so this will be released soon. So I'm using a tenant that is like to come to the to customers. But what is cool is that I added here in my collector. So this is the collector config that I mentioned before. We have receivers, we have exporters, and we see here that we receive OTLP, gRPC, HTTP, and we export OTLP to Jaeger. We also export to logging that actually prints to the console, and we send also metrics to Prometheus. We have some processors and connectors defined, and here the pipelines defined. So the pipelines are traces, metrics, and logs. We see that we have OTLP receivers for kind of all of them, and some processors, batch for all of them, but also for metrics, we use filter and transform, and exporters where we are sending the traces, the metrics, and the logs. And by logs, we are just sending to logging. What I did, I configured an extra config where I'm sending to OTLP HTTP Dynatrace, and I'm sending traces, metrics, and logs to Dynatrace. I configured my token, my endpoint, and if I go to Dynatrace here and refresh this, I can see some logs arriving. Cool. Nothing super fancy here, but what is nice is that if I check the last 1 hour of logs, I'm receiving some logs, and if I take, for instance, this log here, I can see the log. Okay, nice, but I can also go to the trace. So I see the log in the trace, which can help us troubleshoot, like, hey, what is the transaction, where it happened, and what exactly step of the whole transaction it happened. So then we see logs in context. Yeah, but this is not a talk on Dynatrace, so that was just a small parenthesis. And yeah, that was it. Oh, I thought I had extra time, but yeah, the time flew. Sorry. Any questions?
Time always flies. We had another question by Sergio. He was asking what it was take to add something to another language like the OpenTelemetry thing. He was thinking about COBOL, to add OpenTelemetry to COBOL.
Okay, maybe you're working in a bank. I think you can always reach out to the CNCF Slack and say, hey, I'm interested in creating that. What is great about OpenTelemetry is that they have a public specification. Maybe I can actually stop sharing so I see everyone. Yep. They have a specification which defines what each language needs to have in order to be added to OpenTelemetry. So there are, I think, 3 current languages that are trying to be added to the supported languages. One of them is Lua, and I think there are some discussions in Perl or something like that. But you can, of course, check if someone else is also interested, and then you can create what they call SIG, Special Interest Group, and start working on the implementation of the specification in COBOL. I cannot hear you, Johannes.
There was another question from Jackie, but maybe we can have this one still, and then let's stop the recording. Jackie asks, if your language allows all three ways, why would we not want to go with automatic? So are there pros and cons with the automatic instrumentation?
Yeah, that actually comes back to the Sergio question. So the automatic is the easiest way, but it also adds a lot of stuff that you do not have control. So you just trust on the OpenTelemetry and the instrumentation that they will give you. But I think that the best way is that if you are aware of what exactly your code is using, you just go and add the instrumentation libraries for those specific frameworks, and then your code is lighter and it will also start up faster. So it's mainly you have more control on what is running on your application.
Okay, understood.
Maybe one last question from me.
Sure.
We saw that Dynatrace is supporting OpenTelemetry. Do you know any other of the big providers that are supporting that?
Yes, I know that Datadog supports. I know that New Relic supports. There are Lightstep and Honeycomb. They are also big competitors. So, which is great. And with the OpenTelemetry demo, I'm working with most of the competitors, which is awesome because everyone was working on its own demo, and now we just joined forces to work on a public demo that all the vendors can use to showcase OpenTelemetry and their solution. Just one thing, Christian, there is that some vendors do not accept OpenTelemetry protocol. But for those, they within their support, they created exporter for the collector. So they just say, hey, use the collector, send whatever protocol the collector supports, and then export in the, for instance, Datadog exporter. And then they send with the vendor exporter there.
Cool. Thanks, Juliano, for your talk, and thanks for the demo.
Thank you for having me.
Stop the recording now.